Okay, here are the trig derivatives that you guys need to memorize. Okay, so the derivative of sine of x is equal to cosine of x. The derivative of cosine of x is equal to negative sine of x, and so on. So you guys just need to memorize, all right, this trig derivative table. Okay, so let's take a look at our first. Okay, let's say we have y is equal to sine of 4x to the third power. Okay, now here's where you have to be careful first. First of all, let me point out some common mistakes. One, sine is not multiplying with this. So this is not a multiplication, right, operation happening here. So do not use the product rule. Right? You do not use the product rule here. Okay. Two, the other mistake is students will just take the derivative of this, right? They'll say, oh, y prime is equal to the derivative of sine, which is cosine, and then they take the derivative of the angle inside here, and then they'll say, oh, that's 12 times, 12x to the second power, right, using the power rule, and they'll think this is the answer. Okay, this is absolutely wrong. Okay, do not do that. So that's the other common mistake. What you have to recognize here is y is equal to sine of something. Okay, meaning this is a composition happening inside here. All right, sine of some angle, in this case 4x to the third. All right, sine of something. So this is a composition, and as you recall, if you have a composition, you use the chain rule. So you have to use the chain rule for something like this. Okay, so remember that. So let's set up our chain rule. So y prime is equal to the derivative of the whole function, right? So we're going to take the derivative of the whole function times the derivative of the inside function, in this case the angle, right? The angle of sine, the derivative 4x to the third, right? So then let's calculate this. The derivative of the whole thing, now here's where you have to be careful, remember? So the derivative of sine is cosine. And then remember, we leave this alone, all right? We leave this alone. When you're doing chain rule, you leave this inside function alone. 4x to the third, right, times the derivative of the inside now, which is going to be 12x squared, and then we can clean this up. 12x squared times cosine of 4x to the third, right? And then this is our derivative. Okay, so be careful, right? This is not, when you get a problem like this does not mean sine times this, so this is not a product rule type problem. Okay, and don't just take the derivative of this and the derivative of this. You can't do that. You have to recognize this is a composition, so we are using the chain rule here. So we're using chain rule. Okay, in another example, let's say we have y is equal to x squared times sine of 3x. Okay, so for this problem, we do have a product, right? We have a product rule because we have x squared times sine of 3x. So we're going to apply the product rule. So let's set up our product rule. So we have the derivative of the first function times the second function plus the first function times the derivative of the second function. So let's simplify. So we're going to take the derivative of x squared, which is going to be 2x times sine of 3x plus we have x squared times, now here's where you need to recognize, if I'm going to take the derivative of this function right here, sine of 3x, remember this is a composition. So if I'm taking the derivative of a composition inside here, we need to do the chain rule. We're using chain rule here. Alright, chain rule. So for chain rule, I'm taking the derivative of sine of 3x, right, times, remember, and then we have the derivative of the inside function, which is 3x. So the derivative of sine of 3x is going to be cosine 3x. Remember, keep this angle the same. Alright, or we'll keep this function inside here the same. Right, we don't touch it. And then over here is when we take the derivative of the inside function. Alright, times, this is going to give us 3. And then over here we have times x squared. So let's simplify all this. 3 times x squared is 3x squared. We're multiplying with cosine of 3x. Over here we have 2x times sine of 3x. And that is our derivative. Okay. So you have to recognize right here, right, we have a chain rule, right? So this was a chain rule within a product rule, right? A chain rule within a product rule. Okay. Let's do another one similar to this. Let's say we have y is equal to 5x to the third plus 4. Sine times sine 4x to the fourth. Okay, so we have a product rule here, so let's set up our product rule. So the derivative of the first function times the derivative of, sorry, not times the second function, I'm sorry. So let's take a look at another example here. We have y is equal to 5x to the third plus 4 times sine 4x to the fourth. Okay, so we have a product here, 5x to the third plus 4 times sine of 4x to the fourth. So we are going to set up our product rule. So product rule says we take the derivative of the first. We take the derivative of the first function times the second function plus the first function times the derivative of the second function. So the derivative, let's use our power rule. Derivative of 5x to the third plus 4, that's going to give us 15x squared times sine of 4x to the fourth plus we have 5x to the third plus 4. And once again, you have to recognize here, this is a composition, so chain rule, right? Chain rule again right here. Chain rule inside here. So let me set this up. dx. So we have derivative of sine, the whole function, right? The whole function. So sine of 4x to the fourth times the derivative of the inside function. In this case, 4x to the fourth. So this is going to give us the derivative of sine is cosine. And then remember, we keep this inside function the same, so do not touch that. Now we're going to multiply by the derivative of the inside function, so that will give us 16x to the third. Over here we have 5x to the third plus 4. Over here we have 15x squared times sine 4x to the fourth. Alright, so let's clean this up, make it look better. So we have 15x squared times sine of 4x to the fourth, okay, plus 16, you can distribute if you want, it's really, well, let's just distribute it. So I'm going to take this 16x to the third right here, 16x to the third, I'm just going to distribute it in here. So 16 times 5, that's going to give me 80x, add the exponents to the 6, plus 16 times 4 is 64, x to the third, times the cosine of 4 x to the fourth power. And then this is our derivative. Okay? Let's take a look at more. Say we have y is equal to sine of x over 1 plus cosine of x. Okay? Alright, so we've got a quotient here, obviously. So let's set up our quotient rule. Low d high minus high d low. So we have y is equal to our low function, 1 plus cosine of x. That's the derivative of our high function minus our high function times the derivative of low function, 1 plus cosine of x, all over our low function squared, 1 plus cosine of x squared. Alright, so y prime is going to equal 1 plus cosine of x. Right? So we've got this quantity multiplying with the derivative of this. Right? The derivative of this. So remember, right here we have a. Well, it's not going to really matter because we only have x right here, and there's no exponent. It's just a 1. So that'll give us cosine, right, of x minus, we have sine of x times the derivative of 1 minus cosine right here. So derivative of 1 is just 0, okay? So derivative of cosine is negative sine of x, okay? And then let's multiply. This is all over, the low squared. So let's simplify everything, see what we get. So we're distributing, I'll distribute this here. So I'm going to end up with cosine of x plus cosine squared of x, right? Oops, I'm sorry. And then over here, I'm going to end up with negative sine times negative sine is positive sine squared of x, right? And then here's where you need to recognize, wait, cosine squared plus sine squared, that's 1, right? You guys know that, that's 1. So y prime is equal to cosine plus 1, right? Sorry, cosine of x plus 1 all over 1 plus cosine of x squared. Well, these simplify, right? So you end up with 1 over cosine of x plus 1, right, as your final answer. Okay, let's take a look at another quotient rule one. So how about, let's see, y is equal to 4x squared plus 1 over cosine 4x to the third power. Alright, so we've got another quotient rule, so let's set everything up. So we have y prime is equal to the low function, low d high, the derivative of the high function, 4x squared plus 1, minus high d low, the high function, times the derivative of the low function, cosine of 4x to the third. You can put the parentheses right here. All over the low squared. Cosine of 4x to the third squared. So let's simplify. So we have the cosine of 4x to the third right here, multiplying with the derivative of 4x squared plus 1, so that's going to give us 8x, right? Minus, we have 4x squared plus 1 times the derivative of cosine 4x to the third. So remember, this is a composition, so we are going to apply chain rule in here. Alright, we're applying chain rule in here. So let me set that up. That's going to be the derivative of the whole function times the derivative of the inside function, in this case the 4x to the third. So simplify, and then we're going to get the derivative of cosine, which is negative sine. And remember, keep the inside function the same, 4x to the third, times the derivative of the inside function now, which is going to be 12x squared. And then we have, let's copy, let's bring everything down, so I'll have 8x here, times cosine 4x to the third, minus, over here I have 4x squared plus 1. What I'm going to do now is I'm going to take this 12x squared, I'm going to move it over here, this 12x squared. Then I'm going to distribute, alright, distribute it into here. Okay, so then I will end up with y prime is equal to 8x times cosine of 4x to the third. Alright, now I'm going to distribute this minus sign to here and here. So I have plus, right, and then negative 48x to the fourth minus 12x squared. Okay, minus 12x squared times negative sine 4x to the third. Okay, and if you want to, what you can do is, if you want the sign to be positive, you can pull out this negative 1 and then distribute it into here, so it'll make these positive, okay? Alright, so let's go ahead and just do that. So we're going to pull out this negative sign, distribute it into here, so it'll make these positive. So 48x to the fourth, right, plus 12x squared times positive sine of 4x to the third. Okay, and I know I could have just multiplied the negative to make it distribute a positive 12x squared, but I just wanted to show all the steps. So we have y prime is equal to 8x times cosine of 4x to the third. Alright, plus this right here. You could distribute the sign if you want, it's really up to you, you don't have to. All over, remember our low function squared, which was cosine of 4x to the third squared. So here's our derivative right here. Okay?